currently watching video E4.p2-25, which is weather map interpretation. As you have been working through this learning target E4.p2G, which is interpreting weather maps, describing present weather conditions or the current weather conditions, and then predicting what's going to happen to the weather over the course of a period of time. 24 hours would be the example here. So while watching this, we're going to lead you into some information regarding what the introduction and objectives of this lab are going to be, and the materials that you're going to need to gather from myself or Mr. Fuzak to complete this actual activity. Okay, so let's turn to page 2. The brief introduction is located here, just simply talking about looking at and interpreting a weather map and then using that information to help predict exactly what's going to take place currently and as well as in the future, normally over a 24-hour time period. So the objective is that you're actually going to construct an actual map and look at a map to interpret it about the different types of weather patterns that are taking place. The things that you're going to need, you might need paper if you want to draw some things out, do some math calculations, or to just practice drawing these things before you actually put them on this particular sheet. The second would be pen or pencil, your choice. I would suggest, honestly, that you do everything in pencil, including prior to using colored pencils, crayons, or markers and doing color with it, just to make sure you have it done correctly. You can always draw it in without any color and then go back and go color over it once you know that you've done it correctly or that you've checked in with myself or Mr. Fuzak to make sure you've done it correctly. Hard to erase colored crayon, marker, or even colored pencil once you have started to use it on the maps. All right? So there is your objectives, there's your introduction to the actual material and the things that you're going to need for this. What I'm going to suggest is that you take a moment of time and start to read over the procedures that follow on the next page. You'll notice that procedure step number 1 is located here, and then you turn the page over and you'll get to procedure steps 2, 3, 4, and then 5. Once you've completed the brief analysis in brief reading portion that comes with it, then I'm going to ask you to start in on the lab by going back and rereading the lab and the procedures, but this time performing the actual lab itself. So what you're going to do is, while doing the procedures, as it's going to say starting with step number 1, using the weather map on page 2, you're going to notice that the weather map is actually on page 3, so it's a typo on my part, and I apologize for that. But here's the weather map that you're going to be using to interpret information for the questions. Okay, the weather symbol that you see here, again, will briefly remind you of where you find things regarding temperature, dew point, wind direction, wind speed, so on and so forth. So you may want to use this as a reference tool. Although you've completed a lab, the station model lab, you may want to use this as a good tool to go back just for something to remind you, as well as just something that you can look at to help you and assist you. Okay, once you've done that, we'll go to procedure step number 2. What you're going to do is you're going to start by finding the stations that have temperatures of 10 degrees Celsius. And as it says, use a red pencil to draw a line through these stations. So what you're going to do is you're going to draw something that's called an isotherm. And an isotherm is really just something that shows you all the temperatures that are roughly the same. And in this case, we're drawing isotherms at 10 degrees Celsius. And then we're going to show, again, the change in that by moving on to the next one by using the same method to draw isotherms of temperatures at 12, 14, 16 degrees, and then labeling the actual isotherm with the specific temperature that you're showing. So example, for both step 2 and 3. What I would do is, the question is asking for 10 degrees, so you're going to go through and look at all of the temperatures that you currently see on each of these. And you're looking for ones that are 10 degrees. So obviously the first one here that I circled is not one of 10, and you're going to go through and try to figure out which ones are of 10. And you don't want to cross them off like I am, because you may need to reference them a little bit later. But what you're going to do is you're going to look for every single one that has a temperature of 10 degrees. And then from that point, you're going to draw the isotherm, which is more or less a connect the dot type activity. all right, to show the temperatures as they take place. Once you've drawn the isotherm, you're going to now do that with something that is called barometric pressure. And in this case, you're going to use a blue color pencil in order to do that. And you're going to connect all the areas of pressure that are at 1,004 millibars. And then again, you're going to do that in step number 5, is for every 4 millibars, you're going to draw what's simply called, instead of an isotherm, called an isobar. Examples of the ones that you're going to draw are 1,000, 1,008, and 1,012. Okay, so where you're looking for barometric pressure is going to be located on this side over here. These are examples of the barometric pressure that are found on these maps. So you're looking at each of those to then again connect the dots between the barometric pressures of 1,000, 1,004, 1,008, and 1,012. What you'll notice is these barometric pressures are not in the correct form. So that takes us back to one of the activities that you did with the Station Model Lab, which is the barometric pressure conversion. How to convert this specific number here into a pressure that looks like that. So you may have to go back and reference your Station Model Lab in order to do the conversions correctly, talking about if the pressure is above 500 or if it's below 500, adding a 9 or a 10 in front of each of those specific numbers that are listed. So if you need to, you may have to go backwards before doing this, and backwards meaning just flip back to that information. Once you've completed the actual lab itself where you're drawing on the map, you have a series of questions that you'll see right here. Questions 1, 2, 3, 4, and 5, and then 6 and 7 and 8 located down here. And what these will do are going to ask you to use the map which you created here to interpret this weather map and then to explain exactly what weather phenomena are actually taking place throughout the United States on this particular day. And then the last portion is the extension. The extension, as you see right here, is going to be to predict exactly what is taking place with the weather over the course of a 24-hour observation that this map has shown. So we're actually going to look at what's taking place and what do we predict is going to take place for each of these stations. Station A, Station B, and then also Station C. So again, what you're going to do again is you're looking at the current weather conditions and you're going to predict what has happened and record your predictions in the table with columns for pressure, wind, wind speed, temperature, sky conditions such as cloud cover. All right, so for example, we'll look at Station A. Station A is located right here and it is this specific weather station model that we're using for this one. Okay, what you're asked to do is to record the observations as to what has currently taken place. So you can write down your observations as to what you think is going to happen and what is currently happening for the pressure, wind direction, wind speed, temperature, and then sky conditions. Then in this next column, this next row, you're going to write your predictions. What's going to take place over the course of 24 hours based upon your knowledge of how far fronts move in a course of 24 hours. So in this case, we're showing how this weather front and we're predicting what is going to take place over the course of 24 hours as this model, this actual weather front, travels in this direction headed towards Station A. Is it going to land on Station A, meaning that the front is going to be located right over that town 24 hours from now? Is the front going to be out here, so the actual front has passed? So that's what our 24-hour predictions are going to represent? Or is it going to be just in front of us? And is that what our predictions are going to be based upon, is where it is currently located prior to actually reaching us? The same thing can be said for stations B and C. Station B is located right here, and you're going to be making those same what's currently happening and then the predictions. And then the same thing for Station C, which is currently down in this particular area right here. All right, so taking you back to the data table, for each of these stations, you will start by talking about what the current weather condition is at each of these sites. So you're going to write your observations as to what is currently taking place in each of these sites. Once you've made your current observation, you'll write your prediction based upon what you believe is going to happen over the course of the next 24 hours at station A, B, and C. And again, where you get that information from is looking at the weather map that is here and then predicting what is going to take place 24 hours from now. All right? So, should you have any questions, do not hesitate to come find myself or Mr. Fuzak, and we'll be more than willing to help.